Historically, supply chains have operated with forecasting at their core, with the decisions themselves left to the intuition and expertise of senior staff members. Today on Lokad TV, we're going to understand the alternative approach of putting decisions first and understand how this can improve the way an organisation operates. So Joannes, perhaps you can just start off by telling us a little bit more about what do you mean by decision-first approach?
It's a very specific angle that we kind of uncovered after a couple of years doing the job that Lokad does, which is basically predictive supply chain optimization. You know, there would be, first when I started doing Lokad, I would say, the Cartesian perspective, where you want to optimize something. So you say, okay, I'm going to have like data, clarify the semantic of the data, then I'm going to apply, a series of well-defined numerical recipes, forecasting, optimization, and then I'm going to specifically go for specific metrics, and we are going to apply all of that, and then we are going to get good decisions. And it turned out that this approach actually do not work. This is absolutely now not how we actually carry projects nowadays. And the way we do it is very deeply counterintuitive. And when I say decision first, I mean it's literally you have to produce a decision, so something that confronts the reality. What do I mean by decisions, by the way? I mean mundane supply chain decisions, like do you decide to purchase one more unit from a supplier? Do you decide to manufacture one more unit in your production line? Do you decide to move one unit of stock from location A to location B? Or do you decide, to move the price of some product up or down? That's I would say, tangible physical decision that have like a real economical impact on your supply chains. And when I say decision first, I mean that the first step is literally to start by taking one of those decisions before pretty much doing all the rest, which sounds like very, very bizarre, because you would think that all the rest comes first, but no. It's a decision that comes first.
Okay, let's talk a bit about how you sort of came about that idea then. I mean, what was it you experienced at Lokad to kind of come about that?
We realized, when we started, we say, okay, we need to do data preparation. So let's say we want to optimize the supply chain. We need data, just very, again, historical data about the historical, sales, the historical stock movements, this sort of things, very basic, nothing advanced. And you would think that, you can actually document the data, to make sure that you understand the data. And that's what we did. And the problem was, we realized that every single time we were actually documenting the data, we were kind of getting it wrong. But actually, we would not realize that we were getting the thing wrong before we get to the point where we generate the decision. So it's only thanks to the decision generation mechanism that basically we produce a decision, such as, oh, let's move, X unit of stock from this location to this other location. And then we have a supply chain practitioner that just look at the decision and say, well, it's just plain wrong. You clearly misunderstood the situation. We should not be doing that. And there is like a very valid, reason for not doing that. It's not even something very, advanced. It's very mundane. Like you don't have the capacity, or you think that you have 1,000 units left in the first location, but it's completely not true. There is only 5 left. So actually, you can't even move the 50 units that you want to move. I mean, this sort of problem. And so it's interesting. You start by generating the decision, and then you just have like a supply chain practitioners with some experience who just at a glance tell you, this is like a dumb decision. And then you realize that you have like tons of problems that you had not identified.
Yeah, it's certainly very counterintuitive, isn't it? Because, I mean, you talk about those dumb decisions. I mean, surely by doing the data cleansing and understanding how the data is kind of structured, you'd already eradicate some of those stupid, dumb decisions.
Yeah, I mean, dumb problems. I mean, the decisions, they are not dumb. I would say they're mundane. So they are very repetitive. You have a lot of them. But actually, there is a lot of intelligence that needs to be concentrated into generating the decision. So the decision itself, when I say we generate a dumb decision, it means that we generate a decision that just conflicts with the reality of the supply chain in a relatively mundane way. So, and the key takeaway here is to understand that the only way to understand, to make sure that you understand properly the data, is to be able to generate a decision out of this data. And this decision, if it's actually approximately correct, approximately smart and reasonable, then it validates the semantic that you believe is applicable to the input data and that you've used in the first place to actually create the model to generate the decision. But you see, it's a mechanism where you have to go back and forth from the mental model, which is just the semantic, so what you think the data means, to the decision generation mechanism that generates the decision. That is actually the parts where the reality gives you some feedback on what you're doing, and then you will realize that there were plenty of things that you were getting wrong about the data, and so you go back and forth.
Okay, so how do we get to the final decision then? It seems like a lot of trial and error. I mean, how much trial and error does this take?
Yeah,
in your experience?
It's even worse than that, because here I've only discussed about the problem that you've identified about the data, but it's not just the problems about the data. It's also the very metrics that you optimize. Again, if you go for the Cartesian, perspective, you would say you can't optimize what you don't measure. That's engineering principle. And okay, so you need a measurement, and what Lokad advocate is we need to have an optimization that is done in dollars of error, not percentage of error. So basically, you need to have like a metric expressed in dollars that represents all the economic drivers that are applicable. So if we take an example for stock, that would mean that you have economic drivers such as carrying cost, gross margin, stock out penalties, this sort of thing. So this is how you measure, the performance of your decision expressed in dollars. So logically, you would say, well, I take the data that I understand, I take high-dimensional statistical learning capabilities, that's the forecasting part, and then I take high-dimensional optimization, numerical optimization capabilities, and I apply, the metric that I understand that reflect my business strategy, and I understand my drivers, and apply that, and it gives me good decisions. But again, on the metric side, when you do that for the first time, you will end up with tons of nonsensical decisions. And that's very puzzling, because all your economic drivers, they look kind of very not self-evident, but almost, carrying costs, gross margin. I mean, we are not talking of super advanced stuff. And yet when we apply that to decision, we invariably end up with very dumb, poor decisions. And what do those decisions reflect? They reflect that mistakes, tons of subtle problems lies in the metrics themselves. And thus, just like we had with the data, a lot of back and forth between your understanding of the data and then the decision that you generate on top of that, you have a lot of back and forth on the metrics, so the economic drivers, how you understand them, and what sort of decision that you generate.
We always talk about this idea of sort of you can't optimize what you don't measure. So kind of what's the end goal? Is the end goal that the data validates the decisions that you're making, and the supply chain practitioner basically says that makes sense?
The end goal is to have something that that is capitalistic. You see, when we say decision first, the idea is that what we want to deliver is a numerical recipe that generates all those super mundane decisions automatically. Why? Because you have so many of them. You have like thousands of them. I mean, our largest clients have millions of them to generate every single day. So either you have like an army of clerks, which many companies still have, where with a lot of people who go through all day long, through Excel spreadsheet to take these bazillion decisions and revisit all those numbers and all those spreadsheets every single day. Or you decide, okay, I'm going to have like a numerical recipe that does this work. And then all the efforts that I'm still pouring into this area are for the ongoing improvement of the numerical recipe itself. So, but interestingly is when I say decision first, is that until you actually generate those decisions, all the other things that you can do, you're not even sure that they work. That's the thing, because if you take this kind of very, Cartesian top-down perspective, you would say, okay, my plan is first we upgrade the ERP to new capabilities X, Y, Z. Okay. That takes 6 months. And then we are going to document and clarify all the data, and then that's X, Y, Z stuff again, and even push everything into a data lake. And then we are going to do another 6-month study with maybe external consultant to completely clarify the strategy and have a complete modelization quantitative of the business drivers. And then we are going to finally put all those things together to generate this automated execution of the optimized decision. That looks like, the plan with, I would say, the naive perspective on how you could put things together. Is a nice waterfall, outlook where you go from phase 1, phase 2, phase 3, etc. But literally, these things do not work at all. And that was probably the lesson, the most very frustrating lesson, is that until you get to the point where you actually generate decisions, you don't have any idea whether any of the steps that you took before is actually working at all. And that's something a bit shocking. You would think that you could have like I would say a plan that you can execute reliably, etc. But no. But the lesson is, if you don't have this contact with those realities, this feedback loop, you don't know. You really don't know.
Yeah, I mean, the industry is very kind of focused on this idea of forecasting and forecasting accuracy, isn't it? Why is this kind of a view that enterprise companies and sort of consultants push so hard?
Because it's very seductive intellectually. It looks like something very reasonable. I mean, yes, let's do forecasts are important, yes, obviously, because every time you take a supply chain decision, it's basically a statement that you're making about a future state of the market. If you pass a purchase order for raw materials to a supplier, basically you are implicitly making a statement about the state of demand in the future. So supply chain, because we can't teleport and because we can't just, instantaneously 3D print everything, it's all about, anticipating the future state of the market. So there is always this forecasting component. So companies try to approach that rationally and say, oh, let's do, a round of forecasting improvement. That's basically what we discuss in our naked forecast episode. And then you end up with all sorts of problems. And actually, when we revisit from a slightly different perspective, which is this perspective of this episode of decision first, I would say, well, the problem is that you're not decision first when you're doing that. If you say, oh, let's push for better forecasts, and then we will see what we can make with those better forecasts. No, you're not decision first. You're starting with a numerical artifact. Again, all sorts of forecasts are just numerical artifacts. They don't have like any direct influence on your supply chain. And then you say, maybe it will improve. And my feedback is the lesson learned of a decade now of running supply chain project at Lokad is that, no, you're not going to learn anything. Learning only comes from reality, which is the ultimate arbiter of who is right or wrong. And when I say reality is that the way to make sure that this supply chain optimization project is actually doing something that is in the right direction are those decisions, because those decisions are really the crux of putting yourself at risk with regards of what the reality can tell you whether it's actually working or not.
Okay, and putting decisions first is certainly the way that we would look at it. But what about these sort of alternative approaches that are out there in the industry? How about sort of like splitting up those decisions?
Yes, I mean, for example, indeed, what typically happens is that when you start focusing about, I would say, artifacts. So what do I mean by artifacts, especially numerical artifacts? I mean stuff that are supposed to be, I would say, intermediate results that ultimately lead you to decisions. So forecasting are one, forecasts are one type of numerical artifacts, and typically the thing with numerical artifacts is that you have very, very little constraints attached to them. And thus, you can basically kind of, split them, divide them. So how can you do that? Well, you can say, for example, we are going to have like a short-term forecast, a mid-term forecast, a long-term forecast. Okay, you had one problem. Now you have like half a dozen of problems when you do that. Why? Because, well, you had the problem of doing forecast. Now you have like 3 forecasting problems. And now you have also the problems of having different teams that will need to reconciliate what they're doing. So you will need to reconciliate the long-term forecast with the mid-term forecast. And then you will need to reconciliate the short-term forecast with the mid-term forecast, and maybe even the short-term forecast with the long-term forecast. So you see, you had one problem, now you have 6. You've just made the situation worse. And actually, it's still very unclear that everything that you could be doing with that has any connection whatsoever with the reality. Reality will not, tell you whether all you're doing is wrong. I mean, in a very, very indirect way. And I would say, and that's the beauty of decisions. So if we go to this decision first, is that decisions tend to be highly atomic. I would say well-defined decisions. I mean, the way we see it at Lokad, they are atomic. You cannot subdivide them. If I say, purchase 1 unit from this supplier today, it's as atomic as it can get. I mean, sometimes you can even refine. You would say, purchase 1 unit from this supplier today and have this unit shipped by truck. That's because maybe there is like an option to ship it by train, or I don't know, something else. So look at the way we think. We have the decisions. They are as atomic. They are by definition completely atomic. So you can't really subdivide them, which is very nice because also it puts limits on the stuff that you can just made up. That's a good thing about decisions, is that reality has already decided for you what your decision would be. It's unlike, let's say, forecasting, where you can have so many flavors. You can have, regular, what we call classic time series forecast. You can have like probabilistic forecast. You can have people who are saying we don't do forecast like DDMRP, but are actually doing forecasts. It's just that they are doing like frequential moving average type of forecast. So you see, that's decisions actually, by focusing on that and saying that decision first, they also prevent you from doing entire classes of mistakes, such as splitting things, making a lot of, I would say, made-up work that is just not real.
Okay, it's a real kind of change in perspective, isn't it? So what do you do to kind of convince those organizations that are very used to taking a more kind of classical approach?
That's the crux of the problem. It's very difficult to convince because first, I wasn't convinced, myself. I didn't start with this approach back in 2008. I tried the more, I would say, classical way, which I would describe as the Cartesian way. You just try this waterfall principle or engineering principle. Clarify the input, clarify the metrics, clarify the model, and then put all that together to do an optimization in this order, and it will work. And no, it absolutely not the sort of way it works. So I would say I can communicate my experience that it had failed over and over, and we had like, I would say, a vast series of very, very painful initiatives. I mean, ultimately, that's the thing, is that if you do it the Cartesian way, what happens in practice? Well, you're just going to do your nice project, and then once at the day you were supposed to be done, you just realize that nothing is working and you have to do it all over again. And so ultimately, it will work because you get, ultimately, when you actually try to go to production, you will see all those things. And then you will have to revisit all that you've done before. And that's the trick, is that if you don't embrace this perspective, what will happen is that just your projects will just take years. Because you will just do like a one-year project to get it done, you know, in this waterfall perspective, nice plan and everything. And the day you try to turn on the system, you just realize that everything falls apart. So you shut it off again, and you repeat, and then it takes years. So my philosophy is that first I try just to communicate on this experience, and then on a more philosophical, I would say, perspective, I would say everything that you learn, you know. You don't learn, I mean, there might be a few things that you really learn from textbook, but for the vast majority of things in life, you learn by doing. It's actually exceedingly hard to learn anything by not doing it, you know. Yes, you can, in theory, learn a foreign language by just picking a book, reading it for 6 months, you know, just memorizing it, and then down you're fluent. I don't know if I've ever seen anybody capable of doing that. It might in theory be possible, but in reality, no. You would try, you would stumble, and sometimes people would just not understand what you're saying, and then you would gradually get better. But you see, that's you learn by doing, you know. That's the kind of the old Greek concept of praxis. And I think this idea is that for something that is a very complex system, like supply chain, that there is any other way to learn, I think this is folly.
Okay, well, let's start sort of wrapping things up a little bit. But all sounds great theoretically, but I mean, it's far from established. So do you think the industry is really ready to embrace a whole new approach, or do you think it's very set in its ways and the old approaches are too far ingrained?
The funny thing is that in terms of readiness, I mean, I see the vast majority of companies who have been deploying supply chain optimization systems for decades, especially large ones, you know. And I mean, it's insane. They have, I mean, even the term, you know, ERP, Enterprise Resource Planning, stands normally for some kind of, you know, supply chain optimization thing. The vast majority of the ERPs that have been deployed over the last 3 decades do not deliver any value in this area. Yes, they deliver a lot of value on the management side. You know, you can keep track of your stocks. You can have like real-time visibility. It's very nice. You can have a lot of workflow automations for invoices, payments, you know, keeping tracks of delays, all those sort of things. Very good. But when it comes to, you know, predictive optimization, the state of the industry is zilch. I mean, there is very little things that are in place that works, and it's not for a lack of trying. People, I mean, frequently the large companies that we serve, we were typically the attempt number 5, 6, 7 at this thing. So clearly, I think in terms of readiness. Clearly, I think there is a lot of companies are ready to do it because actually they have been trying for the last 3 decades, so it's not like for lack of trying. But I think the crux of it is that most companies have not even tried to acknowledge the fine print of the failures, and that maybe, you know, bounce back to the power of negative knowledge. That's also something that we discussed in another episode. And maybe you need to start. I mean, some companies probably on those problems, on those complex problems, on those wicked problems, or problems that where this Cartesian approach, those kind of problems that resist to this nice Cartesian approach where you can just take a pen and paper, sit on a desk, think hard, come up with a solution, deploy, and it works. No, this is not how it works. This is way too messy. Supply chain is way too messy. You need to generate those decisions, not necessarily, you know, act on it stupidly. You know, you can generate the decision, have some people look at them, and then they will tell you, no, it doesn't work. That's already enough. But you need, and in terms of readiness, back to your question, I think a lot of companies, I think but that's going to be an uphill battle. I mean, for Lokad, we still need to convince them that there is no other way but to put your initiative at risk with regard of the reality, instead of trying to do it right the first time from, I would say, a Cartesian top-down perspective, which unfortunately do not work.
Okay, brilliant. We're going to have to wrap it up there, but thanks for your time. So that's everything for this week. Thanks very much for tuning in, and we'll see you again in the next episode. Bye for now.